Okay, today we're going to be talking about inequalities and their graphs. And I hope you guys remember what an inequality is. So an inequality, remember, in means not, so not equal. Some common inequality symbols are like less than, greater than, less than or equal to, greater than or equal to, that kind of thing. Okay, so a solution of an inequality is any number that makes the inequality true. It could be any number in the world as long as it makes the inequality true. We call it a solution to that inequality. So, for example, I want you to think, what's a solution to x is less than or equal to 5? So what you're trying to do is tell me a number that x could be that would be less than or equal to 5. Okay, so you should have some idea in your head. I'm thinking of 1. Think, how many solutions are there? I hope you notice that, you might have had 1, you might have had negative 42.7, you might have had pi. You should be able to think that there are an infinite number of solutions, okay? There are an infinite number of solutions here. So I'm going to give you another, a little bit more complicated inequality, and I'm going to give you kind of a multiple choice answer, but there might be more than one right answer. Is each of the following numbers a solution to 3 minus 2x is less than 8? So we're going to look at 3 numbers here. We're going to look at 5, negative 5, and 0. And what I want you to figure out is, could these be the value of x and make this equation true? So if 5 was right, we would have 3 minus 2 times 5. Okay, so remember that's going to be 3 minus 10. All right, that's negative 7. Is that less than 8? Negative 7 is less than 8. So 5 could be a solution to this inequality. So yes, it could be. If I try negative 5, then I do 3 minus 2 times negative 5. I want to know if that's less than 8. Okay, so that's 3 minus negative 10. Remember, that's just 3 plus 10. So that's 13. Is that less than 8? No, it's not. So negative 5 is not a solution to this inequality. Okay, try 0 on your own. Okay, so we're just trying it here. 3 minus 2 times 0. Yeah, that's 3 minus 0. That's 3. That's less than 8. So yes, 0 is a solution to the inequality. So all you're trying to do is test, does it make the inequality true? If it does, it's a solution. Okay. All right, we're going to focus most of today on graphing inequalities. So because there are an infinite amount of solutions to so many inequalities, a lot of times we show our solutions in a graph. So when you're graphing inequalities on a number line, you're going to shade the area that makes the inequality true. So you're going to kind of shade everything that would be true. And I'm going to give you a couple examples, but I want to note 2 things. This is probably the part that gives people trouble, if anything gives you trouble in this lesson. Okay, you're going to use a closed dot. Okay, so something like a dot that's filled in at the boundary if the boundary is a solution. And you're going to use an open dot at the boundary if the boundary is not a solution. So I'm going to show you what I mean by this. So for example, I might give you an inequality like this. X is greater than 5. Okay, and we're going to graph these on a number line. So I'm just going to pull up a line, and you can graph a lot or a little on this, but I'm just going to start like 0, and here's 5. I might fill in 1, 2, 3, 4, etc. I'll put in a few, like 6, there's 4, blah, blah, blah. There's some missing numbers. Okay, and what I'm trying to do is figure out everything that makes this inequality true. So all the numbers that are bigger than 5, everything that x could be that's bigger than 5. So like if you were shading, 6 would work, 5.5 would work. Everything that's bigger than 5, so it would get shaded over on the right here. You can kind of see me doing that. And because you might notice like 7 works, 900 million, 0.6 works, everything over there to the right is working, so I draw an arrow to show it keeps going forever. The boundary is 5 because that's kind of where it stops. So the boundary, we want to know, is 5 a solution? So we plug it in for x. Is 5 greater than 5? 5 is not greater than 5, so in this case it gets an open dot. Okay, if I was looking at another number, something like this, x is greater than or equal to 5, we'll just go with that example again. It's my messy number line this time. So this time, x is greater than or equal to 5 again, like the number 6 works, 7, a lot of things, like everything this way is still working. So I'm shading that way, drawing an arrow to show it's going on forever, okay? But if I look at 5 itself, this time, is 5 greater than or equal to 5? Well, yeah, 5 is equal to 5, so 5 actually makes it true. So I'm shading it too, I'm filling it in, okay? So this would be the difference between an open dot and a closed dot. All right. So I want you to try to do these on your own. Graph D is less than 3. And then graph -3 is greater than or equal to G. Okay, and I have some pre-made graphs here, but I'll show you how they work. Okay, so you try them on your own and then check. All right, the first one should look something like this, okay? D is less than 3. All these numbers to the left of 3, they are less than it, and you can see that arrow showing I'm going on forever. But if you try 3 itself, 3 is not less than 3, so hence we give it an open circle. Okay, B, this is tricky for a lot of people because kind of the order switch. It says -3 is greater than or equal to G. So if I try some numbers for G, like -3 is greater than or equal to -4. Yes, that works, so -4 should be shaded. But if I try like -3 is greater than or equal to 1, that's not true. So in this case, the left side is shaded. I could rewrite this if I wanted as G is less than or equal to -3, because I personally do better when I have the variable first. I'm shading everything that's less than or equal to -3. And -3 itself is less than or equal to -3, so hence I get the closed circle there. All right. So you can just see it, like the solutions of D is less than 3 are all the points to the left of 3, and the solutions of -3 is greater than or equal to G. Those are -3 and all the points to the left of it, so -3 counts too. All right. So this time I'm going to give you a graph, and your job is to write an inequality. And I think on this lesson, it's really good if you just practice and see if you can do it before I even show you. Okay, so let's try for, I'll show you all 4 at a time, so you can work on them all and check it out. Okay, so I'm going to write mine. This one, I'm just going to call x my variable all the time. X, and it's everything that's to the left of x, which means all the points that are less than it. So it looks like x is less than 2. 2 does not count. It has an open dot. That would be a good inequality for A. For B, again, it looks like it's going to be everything less. But this time, -3 counts, so it should be x is less than or equal to -3. Okay, see the closed dot, so it could be everything x or less than or equal to -3. If I look at C now, it's to the right, so I'm looking for numbers that are bigger than -2. So it should be x is greater than -2. -2 does not count. It has an open circle, so I'm going to go just with the greater than sign, no or equal to. And if I look at D, I'm going to guess that's 0.5 or 1/2 there. It looks like it's about in the middle. And again, I'm going to the right, so it's all the numbers bigger than it. Should be x is greater than 1/2. Yeah, it's not close, it's not circled in, filled in, so it's just going to be greater than. Okay, when we're here, a lot of times you see like word problems or scenarios, which is a lot of times when you see like greater than or equal to or something like that coming in handy. So we're going to challenge you to write an inequality in this case. So here's my scenario. I want to know all the speeds that violate the law when the speed limit is 55 miles per hour. So I want you to be thinking about what your variable here is. Okay. All right, I'm just going to say, I'll call it x because I don't like s. X is your speed. And we want an inequality for everything that violates the law. So you need to think, does 55 itself violate the law? No. Does 56? Yes. Does 51? No. So it seems like it's all the numbers bigger than 55, 55 not included. So my inequality should be something like x is greater than 55 if x represents my speed. Okay? All right, this one. A job that pays at least $500 a month. So I want to think, okay, what's my variable here? How about like P for your pay? Okay. So would it pay at least 500 if you made 400? No. Would it pay at least 500 if you made 600? Yes. How about if you made exactly 500? Yes, that is at least 500. So it looks like 500 counts and all the numbers bigger than it. So it would be P is greater than or equal to 500. Okay. All right, this is what I want you to think about. So explain to your partner. Your partner today can be your computer. Hey, computer, what is the difference between an open dot and a closed dot in graphing inequalities? Explain it well. All right, and I will talk to you about this and we'll see how you do.